Right, so let's look at inequalities maximum. So let's say 2y plus 1 is greater than 5. Okay, we treat this one just like we do with equal sign. So we send all numbers to the other side. 2y is equal to this coming 5, it's greater than minus 1. Okay, and then we divide here by 2, divide here also by 2. So that y is less than 4 over 2. It means y is less than 2 because 2 go here 1, 2 go here 2. Right, this is the answer. Now, sometimes the same equation, let's look at it this way. If I'm just working it here so that we get the principle. Let's assume it is minus 2y. Then in that case, we are going to have minus 2y plus 1 is equal to, sorry for the sign. We are used to the equal sign. So this is the next equation. Let's look at this one too. In this case, we are going to have minus 2, 5. This is crossing, it's plus, so it becomes minus 1. So we're going to get minus 2y is less than, this is going to be 4. Now we need to divide here by, to get rid of, we want y here alone. So we need to divide here by minus 2 and divide here by minus 2. But immediately you divide by a negative number, this reverses to the its opposite sign. So you are going to get this cancelling out, y becomes greater than, instead of less than, becomes greater than 4 minus 2, which is going to be negative 2. And this becomes the answer. Right, so what I wanted to point out is when it's divided by negative, this sign reverses. So we have these signs, we have that, we have that, we have that, we have that, we have, sorry, we have that. Okay, so we say when it's open like this is the fish. The fish will always eat the big fish, the big number. Okay, so we have 5 and 6. Which one is bigger? The fish must eat 6. If I make it 6 and 5, which one is bigger? The fish must eat 6 tens. Right, so that's simple. So you can get our work examples. I want us to understand the basics very well. Then we'll have the work examples, a lot of them. You have so many questions to solve. So if you grasp this very well, then you can move on to solving the questions. Of course, having done this, you are way through, 90% way through, or almost 100% way through, because the rest will be substitution. Good. So the inequality signs will come in the x-axis, y-axis kind of equation. Okay, so this now x-axis, this positive y, this negative y, this positive x, this negative x. Okay, this to infinity. Negative infinity, and this is positive infinity. So we have 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, 1, negative 1, negative 2, negative 3. So that's it. Now, if you have an equation, let's say y is greater than 2x plus 1. Okay? Now, what you do is, if you work this one out, when you have an expression, whatever expression that you have, this is a kind of a function. Because we are saying greater than, we didn't say greater than or equal to. Let's assume this is the line. Let's assume that's 1, this one. Let's assume this is the line. Okay? Now, if this is a line, when you are drawing it, because it is greater than, it is not greater than equal to. If it is greater than, we need to make it broken lines. That's what I want to point out. Okay? It should be broken lines. Okay? That's broken lines. But if it is this, greater than or equal to, then all the lines should be equal. Okay? And then where it falls, if it is greater than, it falls, you shade where the path is. Okay? And that is for inequalities. This is the basic thing that you have to do. I'm not saying this is exactly what you have there. I'm just giving this as an example. So that if you put in, let's say, value 4, let's say 2 is, let's say x is 2, this becomes 4. 4 plus 1 is 5, so it means y is greater than 5. So we must make sure, why is y greater than 5? Y is greater than 5, and go up, and so on. So that will go up, that is going to be like up there. but I've said this is not the expression for that. So I'm just giving, this was just a figure, an equation I chose. Okay, so you put in, you do that, maybe y is x is equal to 1 and c. X is equal to 1 becomes 3. Okay, so y is equal to, when x is equal to 1, you can put them in x is equal to 1. Here, y is x is equal to, what do you write there? X is equal to 2, y was 5. Then right there, x is equal to 1. X is equal to what? X is equal to 1, we had x is equal to 1, y was what? 3. So see that the numbers are coming here. So in real sense, if assuming this were to be the equation, assuming this were to be the line, then we will have to, because this is where it's greater than, okay, y is greater than, then it will go in after that. And then because it is, if it is this, we need to make it broken lines, okay? If it is that, we need to make sure it's keeping throughout. That's what I mean. So this is just a theoretical one. Right. So when it comes to this one, is you put in figures to see where the y values will be. Where they will be is where you're going to, depending on how the question says it, then you shade accordingly. Right. Okay, so let's move on to the next. We are almost through the discussion for today. So let's look at the let's say we have x squared plus x plus 1 is equal to 0. This is a quadratic equation. It's not function. If it were x squared plus x plus y is equal to y, then in that case we have two variables. So when you put in a value for this, it gives you a value. This can have several numbers. This can have several numbers. But here it's fixed. We have fixed numbers for x. Okay, so that is an equation, and this is function. Right. So let's assume for the quadratic equation x squared plus x plus 1 is equal to 0. It will have its roots or the answers. Okay. So let's assume theoretically from this point. I'm not saying this is the answer. For any, let's say x squared plus bx plus c is equal to 0. Let's assume the answer x is equal to let's say 3, and then another one x is equal to, let's say 5. Okay, so these are the roots of the equation. Now we can also assume that s is equal to, let's say, alpha, and s is equal to beta. Now if we want to set up the equation, so after working out this, we found out that s is equal to 3, we found out that s is equal to 5. This is an example. It doesn't mean s will always be equal. This is a general expression for quadratic equation. Right, so if it is s is equal to that, s is equal to this as any number, then if you are writing the actual product for this part of the equation, it becomes x minus 3, x minus 5 is equal to 0. And that is what we expect to get to that equation. The reason why this becomes x is equal to 3 is because you will say that this x minus 3 is equal to 0, then you see x is equal to 3. That is why it is so. So when you are writing the equation, it becomes minus. Good. So in that same sense, this, if we say x is equal to alpha, x is equal to beta, then we can say that x minus alpha, x minus beta is equal to 0. Now, if we have this expression, this is the expression I want us to work from. So from this expression, then if we expand, we are going to get x squared, this is multiplying that x squared, sorry, minus this one, so x here, x squared minus dx, this becomes minus alpha x, and this becomes plus alpha beta is equal to z. Right, now let me bring the top so that I can write this one well. So from here we have x squared minus beta a and beta s minus alpha x plus alpha beta is equal to 0. Okay? Now, if you look at this like we have done before, we are trying to compare this one with the a squared. Sorry. So dx c is equal to 0. Let's see how things will work out in that case. Now, if you want to get the same expression as this, you would have to divide here by a so that this becomes x squared dx over a plus c over a is equal to 0. Right, now we have this one that we can add in this equation. Now, and that is going to come out as x squared, our minus, because what I'm going to have, going to have beta plus alpha x. Let's see whether it works out. This will become, because this will become minus beta, this will become minus alpha, so it works out. Then you have that equation, alpha beta is equal to 0. If you look at this and compare the two, this equation and that, you realize that from here we are saying that this is x and this is x. We are saying that what the number in front of x here should be equal to this, because this x is equal to that, and therefore this should be equal to that, and that should be equal to that. Right, so that is going to give us minus b, yes, we are minus alpha plus beta bracket should be equal to what beta over a. In that case, alpha plus beta is equal to negative b over a. This is the first equation we want to look at. Right, so it becomes very easy. For this one, straight away it is equal to that, but that's the constant here, that's the constant here. So this will also imply that c over a is equal to alpha beta, or alpha beta is equal to c over a. This is the next expression. Okay, so it becomes very easy for us to get an equation looking at these ones that is 8. Okay, so you see that when you have the equation, the sum of the roots will give you the coefficient of x. Okay, but remember, will give you the coefficient of x, negative coefficient of x, right? And then the product of alpha and beta will give you the constant. So if you are told the root for the equation is 2 and 3, that is alpha and beta. If the roots are added or subtracted, this is what you are getting. So you look at it, so this one has the addition one, and this one has the multiplication one. So if the roots are multiplied, so this times this, we are getting that, another equation, so that issue. If they are divided, this is what we are getting. So you see that the expression that we are interested in here is the alpha times beta, and then alpha plus beta here, for quadratic equation. Okay, we know alpha times beta is the constant. Alpha plus beta is the negative of the x coefficient here. Right. So that is what we have as the root. If you have the roots, this is what we are getting. Okay. So you put the roots in there, and then the answer should work for itself. So from here, we said we are interested in alpha beta and then alpha plus beta. So there can be several expressions for alpha and then alpha plus beta. What you can do, not to commit them to memory, will be to, for instance, alpha plus beta, and then alpha times beta and alpha plus beta. So you can have, if you can ask to find beta squared, or find alpha squared, or find alpha squared plus beta squared. So you see these kind of equations that are coming up, or sometimes can be alpha to the power 3. All you need to do is to look at the question very well. If they are having powers to 2, then the only time you have powers to 2 is, let's say, when you have alpha, let's say alpha, beta, alpha, beta kind of product. This will end up giving you some alpha to the power 2 and then beta to the power 2. Okay? So, because if it is to the power 3, you can add another one. Okay? It can be plus or minus, plus or minus. Okay? So, if it is to the power 3, it means if you have 3, you can get alpha to the power 3 in it. So you can manipulate that equation to get expression. This is what I mean. So let's start with the basic one, which will be very simple. Let me just try and get an expression. And let's see how it will go. So for instance, I can say alpha plus beta. These are the roots that we are dealing with. Roots on themselves. Alpha plus beta. Okay, if I'm to expand this will become equal to alpha squared. This is multiplying that plus alpha beta. This will become plus alpha beta, and this will become plus beta squared. So that I have an expression like this: alpha squared plus 2 alpha beta plus beta squared. This can be rewritten as what alpha squared plus beta squared plus 2 alpha beta. Okay, so I can be told that let's say find the answer for alpha squared plus beta squared when the root is, let's say, 5 and then let's say 6. Okay, right. So all I do, maybe the other expression given to me, okay, this will be equal to a certain number. All I need to do is just find this answer, send it outside there, and then this expression, alpha squared plus beta squared, becomes the equation, and then that will give me the answer. So if you see up to the power 3, power 4, it means you need, if you, to the power 2, you need 2 brackets expression. You can do that to get the expression. If it's the power 3, you need 3 brackets expressions to get your expression. Okay, and then the rest will be manipulations. Okay, so the rest will be manipulations. So depending on what you want. If they say find alpha squared from this, okay, then maybe you are giving beta squared, you can work that one out. So it means this will go and this will go, then you have your alpha squared expression. And that is how it works. Right. So from this, let me just briefly look at an example that we can begin to work. So let's say an equation is given to us 2x squared plus x plus 1 is equal to 0. And then we are asked to find alpha squared plus beta squared, something like that. Here, we know that the general rule is alpha beta is equal to the constant. The constant, which is c over, we have c over what? A. So the constant here, first of all, we must make sure we make this one have no coefficient, or we have only one as the coefficient. So we divide this equation by 2, by 2, by 2. So that the equation becomes x squared plus x over 2 plus half is equal to 0. In that case, alpha times beta is equal to the constant, so it's equal to half. And then the alpha plus beta is equal to what? Negative, the coefficient is negative half. Right, because it's always the opposite of the coefficient is, so it should have been half, but because it's opposite minus, we negate it, and there's it. Okay, so if you are asked to find these are the values. If you are asked to find alpha squared and that, we have the expression alpha squared plus beta squared plus 2 alpha beta. Okay, right, so we can put in the values and then maybe we are giving us, so we just need to, so this means this will be here. Okay, so 2 will be like that. Then we look at the other product. So just substitution, and then depending on how the question is cited, you can get this expression for the answer for this one. So in that case, so this is, because we have said this is equal to alpha plus beta squared. Okay, right. So if you want to find this one, if you are asked, the question says find alpha squared plus beta squared, then we need to send this one across the equation, so that alpha squared plus beta squared is equal to your, so these we are dealing with the roots, the roots for the equation. We are manipulating, so it's about manipulating roots. Okay, manipulating roots. Okay, so this becomes our alpha plus beta. You can find it from here. Here you can find alpha and beta, because you have two variables in two equations. Equation 1, equation 2. You can only find the answer. Okay, right. So let's see from here. From here you can see that alpha is equal to what 1 over 2 beta. Then you can put this expression in here. So in place of in place of alpha, if you put it here, you work it out, you should be able to get an answer for alpha. So we put the answer here. Let's say assume it is 15, and then let's say this one is maybe 30. Put them in, and then this expression will go to that. Okay, we will deal with more work examples. Then sometimes you should remember that we said x is equal to minus b plus or minus bracket of b squared minus 4ac all over 2a. Okay, if you remember very well. Okay, so let's assume this root is equal to b, then x is equal to minus b plus or minus 4 square root of b over 2a. Okay, and this will be, you can have an expression like this, s can be equal to maybe this plus b over 2a, or s is equal to 2a. So this can be one of the roots, and let's say alpha, and this can be the other root, maybe depending on how you look at it. Right. So this kind of, so when you are dealing with quadratic roots, which is a little complex, you can use these kind of expressions to get the roots. Okay. Once you get the roots, you know alpha and beta are in set, and they can play with the question as it is. Right. Okay, so now let's move on to the graph, how to get the graph set and all that. So sketch them, and then the number line. So I have this, and this y, this x, 1, 2, 3, 2, 3, minus, 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 1, 2, 3, minus 1, 2, 3. Right. So the linear equation y is equal to mx plus c. This is a linear equation for y is a linear equation. So you can have this as your linear equation. Now, sometimes you are given only two coordinates, let's say 2 and 3, and then you're asked to divide the equation. If you are given only two coordinates, and then you are given the gradient. Remember, this is the gradient. When it is expressed like this, x is the gradient, this the intercept. Intercept. Okay. intercept on y-axis. Okay, so if you do it, so let's say if this y is equal to 2x plus 4. Okay, let's say plus 1, so that it will be easier for us. Y is equal to 2x plus 1. Let's see how this line goes. Our gradient is 2. So the slope should be that. Now, x, the intercept, y-intercept, that means the line cuts y at 1. Where is 1? So this line is going to cut it through. Now, the gradient is positive 2. Positive means it will be like that. So positive gradient is like that. Negative gradient is like that. Positive gradient is like that. So we are going to have something like that. Now let's see. It's going to cut this. Now you can also put in values. If you want to sketch this line, you can say let y be 0, so that when y is 0 here, this is 0. When y is 0 here, what is x? 2x plus 1. What will x be? Send this across, it become minus 2x. Okay, so we have 1 equal to 2x. Divided by 2, divided by 2. And s is equal to half. So when y is equal to 0, when y is equal to 0, x is equal to what you have here, half. So when y is equal to 0, x is equal to half. Half is somewhere here. Okay? Right, so this is the point. I already said the intercept. Okay? Right. Let's work it out and see. So it causes, it becomes minus. Let's not forget, it becomes minus. So minus, where the minus, it becomes minus 2. Because here it's plus, when it crosses, it becomes minus. Okay, so it becomes minus 1. So it means it will not be here. It will not be here. So minus half is somewhere here. And this is where it is cutting. So the curve is, the line is something like that. So this line is y is equal to 2x plus 1. So how did you get it? We first look at the slope, okay? You can't do it, but the intercept, when y is, intercept is, the constant is where the line cuts y, the line cuts y as x at 1, so we put that one there. Then we let y be equal to 0, y is equal to 0, when y is equal to 0, we find out that x is equal to minus this, so that, you can also say let x be equal to 0. When x is equal to 0, this is going to give you 0, and then y is going to be 1. So x is equal to 0, x is equal to 0, y is equal to 1. It's here, the same point. So that cut goes like that. And that is how you can, that's what you can do to plot the numbers. So in the reverse manner, you can give it two coordinates, let's say 2, 3, and then you ask to find the equation with the slope 4. Straight away, if you are given only one coordinate, then this y is equal to, you have been given the slope, so y is equal to what? 4x, okay, plus your constant. How do you get your constant? So this is where the problem comes. So what you do is we know that for the equation that we have, the gradient, when you say gradient, is let's say m is the gradient. The gradient is equal to the slope, and that slope is equal to change in y over change in x. So change in y means y final minus y initial, x final minus x initial. Right, so the expression given to us, we can put these values here. We are saying that the slope is 4. So 4 is equal to, that's the y minus the y value. This is x, this is y value. Y minus 3, x minus 2. So this is the equation. From here, you can simplify to get the equation. You're going to get 4 into bracket x minus 2 is equal to y minus 3. Okay? And then this one you can rewrite and get what? Y minus 3 is equal to 4 minus 2, like that. So y will be equal to, send this across, 4 into bracket x minus 2, this is becoming plus, it's minus, so it becomes plus 3. And then you expand, you are going to get y is equal to 4x 4 times 9 minus 2 becomes minus 8 plus 3. So that's y is equal to 4x minus 5. This is the equation of the line. So when you are given one coordinate, this one coordinate brings 2, s is 2 here, y is 3 here. This is the point. You are given a local point. So this is, okay? So from this is the equation of the line. Y is equal to 4x plus minus 5. So it means if you want to plot it now, you know the coordinate is here. If you want to plot it, the slope is 4, you will come to it. The intercept on y, that is when y, this is the intercept, the constant is always the intercept on y. So intercept on y is minus 5. What is minus 5? Minus 5 is somewhere here. This is minus 5. So the intercept is somewhere here on y. And this is the coordinate, this is the first coordinate. Then you can keep on like what we said. You can let y be equal to 0. When y is equal to 0, 4 x is equal to what? So 4x minus 5. This becomes 5, and then it becomes what? 4 over 5. So look at 4 over 5, which will be somewhere here. Y is 5. 4 over 5 is somewhere here. Okay? So you can do that, and then you get your straight line. So then you can also say let x be equal to 0. When x is equal to 0, y is equal to minus 5. Minus 5 is the equation graph. So that is how it is. So when you are doing one coordinate, use the same formula. M on slope is equal to changing y over changing this, put in the values, and then you are done. Right, so let's assume you are giving two values. If you are giving two values, then you can tell it. Let's say 2, 3, and then 5, 7 as a line. So in that case, our changing y over changing x is equal to y2 minus y1, x2 minus x1. Okay, that can go. You can also look at it. This is equal to the gradient, which is n. Okay, and so if you have, so in this case, we can find n, the gradient, from these two together, because we have two values for y. So we can say 5 minus 7, which is where this is this. This is that. So that would be. So we have 2 points. The 2 points. This is one point, this is the other point. So this is y, this is y value, this is s value. This is y value, this is s value. So we say y2 minus y1. So y2 is 7 minus y1, which is what? 3.